right, safety features of the circuits that you have in your home can come in one of several flavors. The first one is simply the idea of insulating a wire, right, like with plastic and things like that. And because obviously metals are good conductors of electricity, and so by putting a plastic around a wire, then you are going to prevent that electricity from escaping and reaching you, the user. So when I say safety features, a lot of these are, the purpose of them is to avoid a risk of shock or electrocution to the user who is using the product, right? So there are, so if you have, all wires are insulated, but you can also have something called double insulation. And double insulation simply means that you don't need to, that the entire appliance is covered in plastic or some other form of insulation, so that even if the current escapes and is let, or voltage escapes and is let loose inside the appliance, there's not going to be any risk of it reaching the user itself. So double insulation is when an appliance is entirely covered in plastic. So that any voltage that might be there or any current that might be there cannot reach the user. All right, so that's probably the simplest safety feature. Okay. The other thing that you can have is a fuse. And the fuse, whose circuit diagram symbol looks like that, okay, and it looks like that, oops, sorry, not that. It looks like this because that's literally what it is. It's the little tube, and inside it has a very thin wire. And so the idea is that fuses work because only so much current can pass through this wire, and you can get fuses in different weights. So you can have 1 amp, or not weight, sorry, different currents. So you can have 1 amp, 3 amps, 5 amps, 7, 13, whatever. And so the idea is that if the current gets above that limit, right? So if you have a 3 amp fuse, if the current increases above 3 amps, then the wire inside will melt. So if the current is greater than 3 amps, the wire inside melts. Okay, and what that does is it breaks the entire circuit. And this is the exact phrasing you want to use. You want to talk about the wire inside melts, okay? You don't say that it explodes or anything else. It doesn't. It melts, and that breaks the circuit so that electricity will stop flowing, because if one of the things that electricity needs for it to flow is a complete circuit. So as soon as this wire melts, then it's done. Now, sometimes, so fuses are used and they're present in a lot of appliances, okay? But sometimes they're not, they can be a little slow to act, okay? And also, if they break or if they melt, then it's a pain in the butt to go in and replace them. So a lot of times now, some things have fuses, but almost all houses now are equipped with circuit breakers. And circuit breakers serve the same purpose. The idea is if the current gets too high, then the circuit breaker will be tripped, and it flips a switch, and that again breaks the circuit. Literally, that's in the name there, okay? And the advantages of a circuit breaker over a fuse is that circuit breakers they act faster because you don't have to wait for the wire to melt. I mean, this happens within seconds, if that long, but still, circuit breakers are faster, right? They don't need to be replaced. So if your fuse is broken, the appliance won't work until you go in and insert a new one. But these, you just flip another switch. Okay, and they're more sensitive. So like I said, with a fuse, okay, you get them in certain sizes. So you can get a 1 amp, a 3 amp, a 5, 7, or 13, I think are the standard ones. And so the fuse that you always want to choose the fuse that is the next highest above the current. So the closest number, but higher. But that means that, let's say, for example, if you have a choice between a 7 and a 13 and the current flowing through something is 7.5, then you have to get the 13 amp. And that's a big difference. So you can set circuit breakers to be more sensitive. So you could set it at 9 or whatever you wanted. So in some ways, circuit breakers are often considered to be a better option than a fuse, but fuses are certainly still around and they are used. All right. The other thing, the other safety feature that you need to understand is within the structure of the actual plug itself. So let me get a picture for that. Okay, so this is my picture of a plug, because I'm not going to try to draw it. And there are 3 parts to most plugs, okay? The earth, the neutral, and the live. Notice that this has a fuse in it, if you can see that. And the fuse, if there's a fuse in a plug, it is always attached to the live wire. And the reason for that is because the live wire is what brings the voltage or the current in from the well, the wall outlet, really, the socket, okay? Into the appliance. And so the idea is that this is the energy coming in, okay? The neutral wire completes the circuit. Like I said, you need to have a complete circuit in order for something to run, the electricity to flow. And the earth wire is a safety feature. So normally it doesn't have any current, okay, flowing through it. But if something goes wrong, the idea is that the earth wire provides a low resistance path for the electrons to escape so that it will go into so whatever voltage or current there is inside the plug or inside the appliance will go into the earth wire rather than into you, the user. So low resistance path, that's the key part. And so the idea is that this is the one that's bringing in the current and the voltage into the appliance. So it's the one you want the fuse next to, because if a fuse attached to, because if something goes wrong and the fuse melts, then the idea is you don't even want electricity entering into the plug or entering into the appliance. If you put it on the neutral wire, then all of the electricity would still be going into the appliance, and then it wouldn't have anywhere to go. Well, hopefully it would if there's an earth wire. And so it's much more likely for you to get damaged. So any fuse that's within an appliance is usually attached to the live wire. The other thing to know about this is that, so the earth wire, like I said, it normally doesn't have any current. It's a safety feature. So sometimes you will see a plug that has only 2 prongs. And if a plug has only 2 prongs, that means that you know that that appliance has been double insulated, which is what I was talking about earlier. It means it's totally covered in plastic. So even if something were to happen, there was some sort of short or something, and the current or the voltage were to escape from where it should go, then it's covered in plastic and it doesn't need to have an earth wire. So the appliance is double insulated and has no earth wire. All right, so that's the difference between the 2 and the 3 prong plugs that you are looking at. Those are your safety features.